All right, it is exactly 3 minutes past the hour. We have a good crowd here. This is also recorded so that you can watch this later on. If you've subscribed for this, you will get the link so you can take a peek afterwards. Again, I would like to thank you for being here because back in 2020, when the pandemic started, it was really cool to do webinars. Now we're a couple of years later. It's getting a bit of a drag, I realize. And I also realize that plenty of companies are doing webinars. So I know you have options. So that's why I'm grateful, because out of your busy schedule, you decided to choose this Varnish software webinar. And without any further ado, let's kick this one off. Hello, everyone. My name is Thijs. That's indeed how you pronounce that. I'm a Dutch-speaking Belgian working for Varnish Software as the technical evangelist. Now, the first thing we need to do is address the Varnish bit. If you are either not experienced at all with Varnish, have no experience with Varnish, or you know a little bit and you want to get educated on the topics we'll talk about, but a lot of topics that are related to web acceleration, web performance in general, and content delivery, have a look at this book I've written. It's a new one. It's Varnish 6 by Example. You can buy the physical copy on Amazon. You can also download the e-version for free on our website. So have a look at that. So as mentioned, this is a Varnish software webinar. And for those who aren't really familiar with what we do, we are in essence a web acceleration and content delivery and edge computing company that is specialized in making the web go fast. We are the company behind the very popular open source technology Varnish Caching, which is used by approximately 9 million websites and 21% of the top 10,000 websites. And we also the creator of Varnish Enterprise, and that's the tool we're going to use to do some more advanced things. Varnish Enterprise is built upon Varnish Cache, but tailors to the needs of the more demanding use cases and more demanding companies. Now, a word of warning. This will get technical. And I'm well aware that some of the people in here aren't super technical, but I would suggest and I would invite you to bear with me, because I will explain what the technical things are. And for those who aren't really interested in tech aspects, you will be confronted with them nonetheless, but they'll be very tangible. You will see what the changes I do in code, there'll be a little bit of code, what they mean to the performance of your website. So this will be about performance. And I can explain to you that web performance is experienced in various ways. Now, as a company that focuses on content delivery, web acceleration using caching technology, our goal is to bring responses from A to B in milliseconds. And we do this through caching. So it's pretty straightforward and is client to server. But that's not all there's to it. There's more to the story. And in reality, it's a lot more about perceived loading speed. And you'll see that in this presentation. This one is about perceived loading speed. It's not because the web server with a Varnish cache in front of it manages to serve content in mere milliseconds that the browser will paint it, as we would call it, paint the content on screen within the viewport at the same time. There might be blocking factors. There might be lots of data that needs to be transferred. There might be render blocking that takes place. And we'll walk through that. What is also interesting and what you should know is that the time to first byte and other metrics, as you can see here, are very significant in this presentation. So time to first byte is the amount of time it takes for the first byte to be received by the client. So if your time to first byte is quite high, it means that the server takes a lot of time to complete the creation of the content. And that's where we excel, because if you add Varnish on a website or web platform that has a high time to first byte, you will see that drop immediately. So that's where we are known for. But it's more than just delivering that first byte, because between the first byte and the last byte, there's a lot of things that can happen. And a meaningful metric is the first contentful paint, or the FCP, and measures the amount of time it takes before the browser can render something in terms of content. There's also largest contentful paint, which is, as the name indicates, the time it takes until the largest content block or piece of content is rendered. We'll talk about that in this presentation. You have first input delay, time to interactive is the amount of time it takes before a website actually becomes interactive, scrollable, clickable. Total blocking time, amount of time it takes for, or the total amount of time that the content is blocked. And then we have the cumulative layout shift, which measures visual stability. That's what we're going to talk about. But this is about core Web Vitals. And the core Web Vitals is a collection of Web Vitals that is composed by Google. And this collection tends to change. And at this point, these are the core Web Vitals. We have the largest contentful paint, first input delay, and cumulative layout shift. So let's have a look at the individual ones. Let's see what they're about. Largest contentful paint, as explained, is the amount of time it takes, the render time of the largest visible piece of content. And that could be an image, a video, or a piece of text. Mostly it will be an image. The web has become very image heavy. So the biggest image will be the largest contentful paint that is visible within the viewport. If there's no images, or if the text block, a certain text block, takes in the most amount of time, that will be the largest contentful paint. The trick is to keep it below 2.5 seconds. If that is the case, you're all good. Potential render blocking can also take place, and we'll see that. That means that a certain resource can only be loaded if another resource is loaded, and the largest contentful paint may deteriorate because of that. We have the first input delay, which is our second core Web Vital. It is a time to interactive after an event was triggered. So we have a regular time to interactive on page load. So how long does it take for the website to be fluent, to be interactive upon loading? This one is specifically after an event has been triggered. And this event could be a hyperlink, click, a button press, putting content in an input field, selecting something from a drop-down list, or just JavaScript rendering. And as you can see in the third bullet point, the goal is to reduce browser main thread work. So what that means is, as you're triggering this event, the browser has to do a lot of computation. The first input delay must be kept under 100 milliseconds, and that means that this will reduce the amount of main thread work that takes place, keeps it to an acceptable level. And the last one is the cumulative layout shift. As previously mentioned, it measures visual stability, which sounds a bit vague, but that means avoiding on-screen movement when something loads. And I'll give you a very concrete example. Imagine that you have a text-based website where an image gets loaded. In the image stack in your HTML code, there is no definition of a width or a height. It only sees the source attribute, it only sees the image that it needs to load. Ahead of time, the browser doesn't know how much space it needs to allocate to place that image, to paint that image. If it turns out it gets a bit bigger than expected, than anticipated, some on-screen movement will happen, some scrolling, some shifting of content. That is what you try to avoid using the cumulative layout shift. It is not expressed in seconds or milliseconds, it's just an index, and you need to keep it below 0.1. There's many ways of measuring all these metrics, both the core Web Vitals as well as just the larger collection of metrics related to web performance. There's the Google PageSpeed Insight, which is quite powerful, quite useful. There's a lot of other tools out there in the world, but I will use Lighthouse. Lighthouse is embedded in your Google Chrome browser, in the developer tools, and that makes it quite approachable. The thing is with Lighthouse is that it's more of a lab testing tool. It doesn't do it on production sites. It doesn't do real life scenarios. It does mostly simulations. And it presents the following metrics. It includes a bunch of core Web Vitals, also some other ones, like first contentful paint, time to interactive, total blocking time, but also largest contentful paint, which is a core Web Vital, and the cumulative layout shift. First input delay is not part of this, unfortunately. Now, that is because it's more of a lab testing tool that loads pages rather than doing triggerable actions and scenarios related to that. But time to interactive will give a solid indication if things are blocking. And that also applies to total blocking time. So that's how we will do that. You'll see that in a minute. It'll be front and center. It is important to define the role of Varnish in this. People who know Varnish know that Varnish is primarily good at keeping the time to first byte very low, but surprisingly, you will see that we can do some other elements by changing the HTML that is presented and ensuring that the browser can process this in a better way. Now, just for reference, it's important. Normally, when a user connects to a server without Varnish, the user gets the response directly from the server. But the risk that is involved is if there's many users contacting the server or requesting the server at the same time, the server may become overloaded, overwhelmed, and response times can increase till a point that the server no longer responds, maybe goes out of memory, has too much load, and becomes unresponsive. The way we tackle this is by adding Varnish. Varnish is a server, a web-related server. It's not a pure web server, it's a reverse caching proxy, as we call it, that acts on behalf of the user and the server. It sits right in between. And the user obviously, or thinks that he's doing an HTTP request to a server, but in reality, it's Varnish that proxies the request on behalf of the server. If it doesn't have the content stored in cache, it will forward it to the server. As soon as it has a cacheable response, it will store it in the cache and will continue serving it for the lifetime that was defined by the server. So basically, it takes away a lot of the load from the server. That's a bit of an origin shielding pattern that we apply here. And that is how we will improve both the absolute loading time, the time to first byte, time to last byte, but also the perceived loading speed due to the various metrics that I've presented. And a lot of it will be done using the Varnish configuration language, which is our own programming language. Varnish doesn't simply use a configuration file to define certain rules. No, you get a full-blown programming language that has specific capabilities like request handling, request routing, manipulating responses, which we'll do plenty in this presentation, selecting specific backends, controlling how the cache is used, but also doing, and that is what I really like, is making decisions on the edge. And I'm using the air quotes here. It is making decisions that have an impact on the business logic, on the way content is perceived in Varnish, which we call on the edge rather than on the server. Because if we do it on the server, it will probably imply that data cannot be cached and you bypass the cache. So on the edge is a key word, not just in this presentation, but also in the larger web performance and content delivery ecosystem. So what we'll do is we'll optimize the perceived loading speed with Varnish by manipulating the HTML that is sent. And this manipulation is done using a collection of Varnish Enterprise VMODs. So let's have a look. The rest of this presentation is demo time. There will be some time for Q&A in the end, but let me show you what we've got. And as mentioned, it will get technical, but don't worry, I'll be right there with you to guide you throughout. So this is a website, sort of hypothetical demo website that I've built myself that is pretty slow. I created it to be very, very slow, perform poorly, and it has all the bells and whistles that you need to make it a typical use case. So don't mind the content. The content is pretty boilerplate. I added some text. I added an image here that takes up some resources. I'm not sure if the resolution of Zoom does it justice, but there is a light background image. There is some CSS and some JavaScript to make this behave the way it behaves, and the CSS to imply a level of styling. What I'll do is right-click and go to Inspect and open the Network tab in my Chrome browser. And this will present a waterfall representation of how this is loaded. Mind you, you have to have some patience sometimes because I deliberately made this slow. So I'm going to refresh the browser and make sure the browser caches are emptied, and then you will see what is going on here. Don't worry, I'll guide you through the process and show you the important metrics here. Now, if you look at it visually, you see that we start on top, then there's some waiting time. This is the main website. This is hosted locally on my system. This is a document, so this is the HTML page, and it takes 1.8 seconds to load. It is blocking, as you can see, and then a bunch of resources get loaded. 2 CSS files, 2 JavaScript files. This is their size. This is a bit too big for my taste, and it takes a bit too long as well, so we need to improve. Then you see that it takes some time. There's some blocking taking place. If I hover over this, you see that the queuing takes 2.33 seconds. So for 2.33 seconds, the browser is not really doing nothing, but is waiting until these resources come in before the images can be loaded. And then in the end, when the full thing is loaded, the fave icon is transmitted. All in all, we need to transmit 7.4 megabytes, which is gigantic in web terms. So we need to improve this heavily. And it also took more than 7 seconds to load this. Now this can vary. I will refresh again. We'll see what's going on. If we hit those same times, you can see the data that we're transmitting. Yeah, it's pretty much the same. Let's do some Lighthouse. So I have a Lighthouse tab here in Chrome. You should have that as well. If you click it, you can create performance reports. There's plenty of other stuff, but that's not the purpose here. We're talking about performance. I'm going to do it on the desktop. I'm going to generate a report. It does an audit in a more lab setup. So it does multiple runs. It tries to figure out what is going on and will present its results in a couple of seconds. Now, of course, the slower your website, the more time it takes to generate this. You can do this for your own website if you want to see how you are faring. As expected, the performance is really poor. It's 47 out of 100. We're getting a 47%. And you can see here that if you score between 0 and 49, you're doing really bad. Between 50 and 89, you're doing okay. And from 90 to 100, you're doing good. Then you see the key metrics here. First contentful pane, speed index, largest contentful pane, time to interactive, the blocking time, the layout shift. But if you click expanded view, you will be able to see what these things mean. And I encourage you to click that so you can understand what is going on. So this thing is really, really slow. But we can scroll more down, and then you will see some very tangible call to actions. In the opportunity section and both the diagnostic section, you'll see some things colored either in red or orange based on the severity. It says quite explicitly that we need to eliminate render blocking resources, and it might, because it's estimated, might save us 7 seconds of loading time is what it expects. So if we drill down, we can see that there's a bunch of resources. Like this JavaScript file takes 2 seconds. The Bootstrap bundle takes about 2 seconds. Everything almost takes between 1.5 and 2 seconds. That is unacceptable, and it's also blocking the rest of the rendering. So we need to get rid of that. Serve images in next-gen formats might save us 3 seconds. If we collapse that, then we see that this background image is gigantic. It's almost 7 megabytes, totally unacceptable. And then we have this image that we need to do some work on as well, 73 kilobytes. So that will happen throughout the session. But of course, and I think that is our priority, reduce the initial server response time. 1.7 seconds is unacceptable. And then we have some other stuff going on. So let's do that. Let's improve. So this is where I take you to my editor. This is my VCL file. VCL stands for Varnish Configuration Language, as I've explained. And this is where you will write the code. I deliberately, I need to explain that in a second, did return pass to bypass the cache. So now we're going to take that away. This is not a top-down programming language. This is a language that hooks into various elements of what we call a finite state machine. So there's a flow in Varnish, and you can hook into several moments, like key moments. Here's a key moment, VCL receive. So that means a subroutine that hooks into the receiving part. Actually, my content might not be so random after all. This is the flow. So you start a request, and when a request is received, you enter the VCL receive block. And this is where we're at right now. So I'm going to switch this from pass to hash. And this will explicitly cache everything. Now, in production, you might not want to do that, but for the sake of this example, which is a very static example, this will serve us quite well. So let's do it. Do a Varnish reload, maybe also clear the cache. This has all been done live, so we hope that the demo gods are willing to help me out here today. Takes a little bit of time. We reloaded the config, we cleared the cache, and now I'm going back to my inspector. I'm going to see what's going on. So I'm going back to the network tab. I'm going to refresh again, and it will take the same amount of time. Maybe a little bit longer, maybe a little less long, but initially things won't be stored in the cache. So it took 5.82 seconds, which is slightly better, but not enough. If I refresh now, things are way better. So what have we learned so far? That we've dropped the loading time from, what was it, 1.7 seconds to 19 milliseconds. That's blazing fast, that's super fast. But again, that is absolute performance of individual resources. The background is still a bit slow, 200 milliseconds. Again, that's 7 megabytes, but the total loading time is 298 milliseconds, but still 7.54 megabytes of data being loaded. So we're doing quite well. So the DOM, which is the object model with all the bits and pieces of HTML, was loaded in 74 milliseconds. but it was all the rest that was dragging us down. So what I want to do first is I want to make sure that what we're sending over the wire in terms of textual data, and that's an important side note. So what is textual? This CSS file, 2 JavaScript files, and this SVG image. The SVG image is our logo here. These are textual. I will show that in a minute. These are human readable. Maybe I should click it and show you. If I click this resource, it will open it up. This is the CSS file. This is human readable, but uncompressed. Normally, your web server would compress this if you've configured it so. I deliberately configured it not to be compressed so I can show you how to improve. So I'm going back to my VCL file, and I have my optimized VCL here, which is my cheat sheet, so to speak. So we're going in here, and we're going to paste this, remove this, add a closing bracket. Allow me to explain. The first thing we need to do is explain why we are in VCL backend response. And we're quite lucky, we can go back to the diagram here. VCL backend response is located here in this gray box. This is only called when you're not serving stuff from cache. When you cannot serve something from cache because it's either a miss or you've bypassed the cache, the fetch needs to happen. And when the fetch is done, the data that is served from the origin server is then fed to Varnish. So VCL backend response kicks in just before we store the objects in cache. I'm glad I put the flow chart here. I'm going to go back to the network tab, take you here. So what happens if you enter VCL backend response? We have some conditional logic happening. If, so conditional, if the backend response, that is what BRESP stands for, contains an HTTP header called content type, and it matches a pattern text application, or it matches image SVG plus XML. Don't worry, I'll explain what that means. If this is textual data, if that is received, we're going to bump the TTL in the cache to a day. So we'll store these things in the cache for a day, regardless of the caching status that was announced by the server. What we'll also do, and Google likes that, Google PageSpeed Insights, as well as the Lighthouse, is to add a cache control header, override that, and send it to the browser. And this is measured in seconds. I think this is 30 days, if I'm not mistaken, to make sure that the client, the browser, will cache it for longer than necessary. And here's the kicker then. We will also compress the output using gzip compression. This is something that browsers support. I can prove this to you. So let me load it again. Click here on localhost and a window opens and we see the response. What is the response of this HTML page? That's that content type header I told you about. It's text HTML and then there's some data behind it. It is how this data is encoded. It's using UTF-8 Unicode character sets, but we want to match text HTML. Another thing you can see is content length. This is 1547 bytes long. We want to compress that a bit. What is also interesting to know is what the browser supports. The browser supports encoding. The browser, in this case Chrome, announces that it supports gzip, deflate, and BR encoding. Gzip is like regular zip, right? It compresses something, makes it smaller, and the browser supports it. Varnish supports it as well. So let's see how we improve, see how we fare. So we have this in play. We're going to reload everything. There we go. We'll go back to the browser, reload the content. And again, it will be slow. We expect it to be slow. But remember that 140 kilobyte resource here, this bootstrap min.css, well, it has now been reduced. It is no longer that kind of size. As you can see, the size is now 21 kilobytes. Main.css was reduced as well. This jQuery is a lot smaller over the wire. And also this SVG. And I need to tell you about an SVG. An SVG file is actually a sort of illustration. It's not a pixel image like you have JPEGs or PNGs, like a typical images you know on the web. If I double click this, it will open it up. You can't really see much. You see a little bit of blue, but that's because the main text is white. But what you can do with an SVG that you cannot do with a regular bitmap, like a JPEG or a PNG, is you can view the source of the page. I'll bump the font size a bit. So as you can see, SVG just looks like HTML, and it's actually a vector image. So that means you can scale it to the size that you want without reducing quality. The trade-off is that you need to describe, but mostly you could do this in Illustrator if you want and save it to SVG, actually describes all the fills, all the positions. So it actually is a textual representation of what the image looks like. So this is also compressed. We've done a better job. But, and that is what still annoys me, this image is still 7 megabytes and takes in most of the time and most of the space. It still takes 3 seconds. But if I load it with the cache loaded, it takes me 200 milliseconds, but it's still 7 megabytes. Because images, like a PNG file, we cannot compress using gzip compression. So we need to improve a bit. And for that, we'll use a Varnish Enterprise vmod called vmod image. So I'll already load the vmod. I do this through import image. And then again, we'll go to our cheat sheet and steal a little bit of content here. I'll explain in just a minute what is going on here. We also need to load another module called header plus. And I'll take a bit of time to explain why we need this. Because these are important concepts. They might seem a bit too technical, but all in all, they make a lot of sense. So again, we're in VCL backend response. This is where we're at when the backend responds with content that we need to cache. We check the content type, and and this is a regular expression pattern. So this means if whatever the content type is starts with image and then whatever, of course, we're dealing with an image. So what we're doing is we're boosting the time to live. We're caching this for a day. We're also putting in this very same cache control header so that the browser caches it for a month. But then we're going a bit deeper. Then we're saying, what if the image is actually a JPEG image or a PNG image? Well, in that case, we'll try to reduce it and use WebP. WebP is one of those modern image formats that is specifically designed for the web. But we'll only do that if the browser accepts that format. So what we're doing is checking whether or not the request that was sent to the backend has an accept header containing image WebP. So it's time to show what that means. So we're going to the browser. Here's an image, the background's PNG. If we click here and go to the request headers, this is what my browser is telling the server. I can accept for images, image AVIF, which is an image format. I support image WebP, which is crucial because that's what we're looking for. It is part of that string. Also APNG, SVG, and then any other conventional image format. So we're lucky. We know that it's supported, and I will simplify the situation quite significantly here and throw some stuff away. We'll build this up as we go. There's levels to the story and layers to the story. So let's start from a simple attributeless, parameterless function. If we're dealing with a JPEG or a PNG file, and if our browser supports WebP, then we can decide to convert it to WebP. We call image, which is our image vmod that I loaded here, call WebP, and then it will dynamically be converted to WebP and stored in the cache. So even though you're calling the background using background.png, we will serve a WebP image. But we need to ensure that there is a variation stored in the cache for browsers that support both WebP, but also for the ones that don't support WebP. Because if a browser doesn't support WebP and we serve a WebP image, that will be gibberish and that won't work. So that's why we need header plus, assign a vary header that says, please make sure that if you store something in the cache, you do it based on the accept header. So that means if there is no WebP, you have a traditional version, and if there's WebP, you have the WebP version. So let's do that. Let's see it in action. Reload the config and empty the cache. And now I will do a little bit of what may seem magic, but will make more or less sense. This is the command line, and on the command line, we can type commands. And one of the commands I have is curl. And curl is like a browser or web browser, but a textual one. I will type some commands, typical magic here, and go to localhost/static/background.png. This is our background image. What we learn here is that the content type is image PNG. We're dealing with a PNG image. This is the size, still 7 megabytes. the AH header is 0. That means it wasn't stored in cache. But if we do this again, it has been stored in cache for 2 seconds now. The size is still the same. It's still a PNG, and that's a bit of a pity. That is not what we really want, because in fact, we want WebP, but we didn't announce any support. As you can see, there is a vary on the accept header. So what I will do now, for your convenience, I will clear the screen, take my command, and add that header. So I'll say accept image WebP. We're announcing WebP support. And now it takes a lot longer because Varnish is now converting this PNG image into a WebP before it can store it in cache. That takes time, unfortunately. So bear with me. Might take 10 seconds even before this happens. Of course, this is happening on a very small server on my local machine with limited resources. In production, you'll probably have a beefy server that will handle this for you. And most likely, you will not have something that consumes 7 megabytes, like doing a 7 megabyte background image is a bit ridiculous. However, I've seen it happen in real life. So what you see, we're calling the same URL, localhost static background.png, but now our content type is different, image.webp. And as you can see, let's have a look here. It has been stored in cache for 27 seconds and the content length is significantly small. So if you have to do very rough calculations, we've went from 7 megabytes to 64 kilobytes. That is quite spectacular. So let's go back to visual mode. We'll refresh this. Of course, not everything was stored in the cache. Things are still relatively slow. It takes time. And this is, I would say, not normal that the background image would be loaded again and not be served from cache. But we're having not really a problem. It's something I expected that would happen, and we need to clean that up. So if I look at any image here, let's take this one. The accept value is not just image.webp, it's image WebP and a whole bunch of other stuff. So as soon as this single string varies slightly, even the order is different, it's a different string, and the browser doesn't see the variation in the cache and will start rendering it again. This is something we need to avoid. So let's see if it is loaded now. Yeah, it took about 30 seconds, which is unacceptable from that level, and we'll optimize that in a second. But what we see now is that our 7 megabytes of loading time, loading has been reduced to 181 kilobytes, which is quite a dramatic shift. But if we decompress the content, we are left with 409 kilobytes. So if we refresh that, things are super fast. So our entire page loads in 83 seconds, whereas the main content loads in 16 milliseconds. That's quite brilliant. Now let's clean up the trash and ensure that this cache variation shenanigan doesn't happen again. So we have to copy some code. Let's do this, remove that. And again, allow me to explain what is going to happen. I'm going to import an additional Varnish module called vmod accept. This is an open source one, ladies and gentlemen. This is wide open. You can download this, you can compile this, but for your convenience, if you're a subscriber of Varnish software, if you're an enterprise client, we package this automatically. And what it does, it looks at the accept headers and reduces them to their bare minimum. It reduces the amount of variations, which is important because you've seen the downside. The more variations, the lower your hit rate. So in the initialization stage, which happens before requests are received, we're using the accept vmod and calling the rule function to define an accept rule object called img, short for image. This is our fallback value. So if we don't recognize any of the values that were sent, we're reducing it to image WebP. Other than that, we accept image WebP, image JPEG, image PNG, and this SVG image. And then when we receive a request and the extensions match, extensions for the URL like a JPEG file, a JPEG file, a PNG, an SVG, or a WebP with any other data attached to it, we'll call image.filter and filter down the results so that whatever we get is a reduced format of that. So if I go back to the browser here, take this very long string that you'll see here will be reduced to WebP. And that is sort of convenience that we're building in. Maybe I will reload it again. We should look at what we have in terms of core web vital score in Lighthouse. It would be a pretty good idea. But first we need to, the demo gods aren't too happy right now. A little bit of an interruption, but now we've recovered. This is slow because it's the first request. Let's do this again, and we're doing well. Things are looking good. I'm going back to Lighthouse, and I'm clicking Generate Report, and I'm expecting good results here. Now, I've done the test a number of times. We always got good results back, so let's see if I'm not jinxing it. While we're waiting, it's giving a little bit of advice. It's almost done. 90. I was expecting better, to be honest. I was expecting 100. So wasn't like I wanted it, but again, we're not at the end of the session. Let's have a look at what it says. There is some render blocking taking place, and more specifically, the CSS and the JavaScript is blocking us a bit. We need to cater to that. There is an image out there that has a width and a height that is missing. And this is more specifically our little logo here on top of the page doesn't have that and would impact the CLS a bit, the cumulative layout shift. So let's figure this out. Let's fix this. We're going back to the VCL, going to optimize. And now we're going to do some things that modify the HTML code. We're going to grab this piece of content right here, and we're going to paste that. Let's see if we need to do other stuff. Nope, all is good. So what's going on here? If the content type starts with text HTML, if it's an HTML file, then reduce the TTL to an hour. We don't need it in the cache for a day. HTML content changes. Static stuff like CSS, JavaScript images tend to stay in the same format forever. We're setting the cache control header. And here's where it gets interesting. First things first, let's import this Xbody vmod. It's a Varnish Enterprise vmod that is responsible for modifying the body. And we can do this using regular expression patterns, which is a quite technical term, but what it means is it's a sort of find and replace using patterns rather than explicit strings. This is, ironically, a more explicit string. We're looking for a link tag, static main.css, and we're going to inline it. I'm going to comment this out because I want to show you something in a minute. So it will replace this link tag that can be found in the source code. I'll show that in a minute, and inline this with an edge side include, another technical term that I will explain. It will look for that SVG image, that logo, and will also inline it. And what it'll also do is look at the script headers, the script tags that cause render blocking, and add a defer keyword to them. And this defer keyword will ensure that they're not render blocking, but executed in the background. So it's time to take you to the source code of our little website. Here it is. This is HTML. Not too scary, I'm hoping. This is not an actual programming language. It's a markup language. And if you're into web, this should probably make sense. This is a link tag that refers to a style sheet. And this style sheet is CSS. If I click it, you will see a lot of code that is minified, that is solely responsible for visualization. It's by Bootstrap, so it creates the nice layout. We have another piece of style sheet here. If I click it, you see that it's very small and easy to read. What it does is it's responsible for making images 100% wide and an automatic height, but we're loading the background image here. This is where it comes from, that 7 megabyte image that was reduced in size. Well, that's where it came from. What you'll see is that there's very limited amount of lines here. So the question I'm asking myself is, why am I loading this separately? Why am I wasting a round trip, as we call it, on it? wouldn't it be better to inline it? And that's what we're going to do. We're going to inline this so that the content from main.css is actually printed here and cached separately. These are our render blocking JavaScripts. I deliberately put them in the head tag. Things that aren't too important for the initial visualization could actually be put in the body tag and will be loaded later. But I deliberately did it poorly so that we can add the defer keyword so that these will be loaded asynchronously. And then we have our little vector image, our SVG file that is loaded in this image tag. And Lighthouse is complaining that there is no height and no width. But since this is human readable and this is no longer should no longer be a strange concept to you, I'll click it again. I'll show you the source, not the inspection, but the source rather. Well, we can load all of this in line as well. It is XHTML style, so this is a tag. We can load all of this content right here in this div. And that's what we're going to do. But before we're going to do that, I need to show you what edge side includes are. So I've commented this out. We'll comment it or uncomment it later. We're replacing these markup tags with some other HTML, but with this ESI thing. And that's actually placeholder technology that gets parsed on the edge. So that means this find and replace will put these ESI tags here, have a source attribute, which refers to, corresponds here, static main CSS, and here it's the logo. And I'll show you what will happen if we don't process ESI, if we just do the find and replace. So I'm reloading and emptying the cache. I go back to my source, and when I refresh it, it takes a little bit of time, but here you can see those ESI tags. They're not processed. This is not something that the browser does. This is not something that the server does. This is something that its Varnish is supposed to do. So Varnish will be able to inspect this, and when it sees the attribute, the source attribute, it will load the file, store it separately in cache, but still display it in line. And that is what will happen right now. I will uncomment this line to enable ESI processing in Varnish. And again, the typical reload and empty cache. See if it's done. Yes. And now this will be replaced with the CSS. This will be replaced with the actual SVG. And mind you, the defer tag is already there. We've already succeeded in that. So reload. And there we go. Here is our inline content. We've just modified the HTML, but using find and replace techniques and edge side includes. And the same applies to the SVG image. We've reduced some of these aspects, and now we can reap the benefits. We go back to our inspector, take you to the network tab, reload. Not everything is stored in cache, of course, only the source file. So the HTML file was initially stored. Let's refresh that. Again, the background image is taking its jolly time to load because Varnish needs to take in that 7 megabytes, needs to convert it, needs to store 2 variations in the cache. It takes time. Yeah, it took 22 seconds, which was quite a lot. But now we can see interesting things happening. If you look at the waterfall, it used to block directly here after this resource. What you already see is that there's only one CSS file. The other round trip is no longer there. So we've saved ourselves back and forth. But the bootstrap will be reduced in size and will no longer be blocking because we've deferred it. And now all of a sudden, this logo and the background image which comes in later can be loaded faster. So our render blocking is no longer a huge problem. Allow me to take you back to Lighthouse, generate the report, and see what's going on. And we have 100. Our first contentful paint is in 0.3 seconds, which is great. Our largest contentful paint is 0.4 seconds, which is also really good. We're supposed to stay under 2.5. We're significantly under. There is no cumulative layout shift. All the key aspects are gone, and we have a really fast website. So that is how we fared. So what I also see in the chat is that someone says that like having a speedy and sane backend is essential, and that it's relevant for images too. Your backend should serve sane content, and that is 100% true. So thank you, Axel, for mentioning that. What I'm showing you here is a situation where either you don't have the skills to do this in your code, or you don't have access to your code. And that's where Varnish can do things that were normally intended to be done by your front-end team. If you don't have a front-end team, or if you can't access the code, or if you want to put this in our labs, we can do this in a managed way and we can improve it. What I want to show you is that there's a thing called the core web vitals here, and we can go beyond our regular responsibilities, because 9 times out of 10 we'll be responsible for accelerating the individual requests. Again, I will show what that means. If I go to the network tab, empty this cache, making sure these are individually fast, 21 milliseconds, 16 milliseconds, reducing the size, 2.9 kilobytes. Remember our background image, 64 kilobytes. We can further reduce it. I told you it came in levels. Well, maybe as a sort of closing note, let's do that. You can further reduce the image size. Grab this, replace it here. So what happens is, if we spot that the request is for the background, we won't just convert it to WebP, we'll reduce the quality to 70%, which will have a big impact on the file size. And what will have an even bigger impact on the file size is that we're actually resizing the image. Why do we need an image that is huge if we can reduce the size to 1920? And for the other images, we'll reduce the quality to 80% and with a width of 800. So this is the final note before we go to Q&A. Reload. Let's hope that the image can be loaded fast enough. Now, for all intents and purposes, my backend is not well behaving, and I deliberately made it so that it is poorly behaved. But in reality, I hope for you that your web server does a bit saner things, like already encoding it via gzip, making sure that things go faster. What you see here, let's go in. We started with a background image that was 7 megabytes. Then we reduced it to 64 kilobytes. Then we resized it and reduced the quality from your default 80% to 70%. And now we're sitting on a 12.8 kilobyte image that is loaded in 12 milliseconds. Talk about positive results. And if we double click, you can see, and again, I'm hoping that Zoom does it justice, that it's pretty much okay for a background image. Like if you view it here, it's not that strange. So that's it. We're at the end of the session. I'll take you back to my slides. So we're past demo time. I hope for the people who aren't technical that it was tangible enough that you can actually see the impact of the bits and pieces of code. Now, don't worry about the code. If you have technical people, they can be onboarded into this process. If you don't, we can do this for you. What I would like to mention, though, is that we'll be in touch with you if you've signed up for this. So we'll have someone contact you, and then you can leave some more feedback if you don't want to do that in the Q&A. If you have interest in what we've shown you, you can tell that to the people that contacted you. So without any further ado, this is the end, and I would like to go to Q&A. So, but I also see some stuff in the chat that I will include into Q&A. So I will quote Christian here saying, are these modules enterprise modules, or could this also be achieved with open source modules? Like the key things that you've seen here are done using enterprise modules. Then again, if you have the skill set to turn your images into WebP images and to optimize your HTML, you won't need them. But if you want us to do this, well, we use these images to make these conversions on the edge without you having to change either your development flow or your deployment flow, because in a lot of cases, these images will be converted into WebP in this sort of build pipeline. Another question is, can we use Varnish Enterprise also for Magento? Absolutely. I've had some conversations with the people of Magento, and I still believe that we can do a lot with that. We've done webinars in the past about e-commerce and how our edge-based technology can further reduce the load on Magento, especially when it comes to more interactive things. Like for Magento, it's quite easy to just cache a page, a product page, and cache the images. But when it comes to like the checkout process, or when it comes to like dealing with shopping carts, things get a bit more tricky, and I do believe we have value. Then another question, like, is Varnish supporting SSL, especially multiple HTTP2 requests? Yes, absolutely. This is not part of the context because otherwise I would have to explain all of this. But yes, Varnish, both open source and enterprise, support SSL. Only our enterprise solution supports it natively. Other than that, you should have a TLS terminator, and we would advise you to use Hitch, which is our own open source TLS terminator. It supports HTTP2, so you have two birds with one stone. This can be loaded over HTTP2 and take away what we call the head of line blocking problem. So yes, Christian, HTTP2 is supported. We support TLS using the Hitch TLS proxy, which is efficient, but we also support native TLS if you want to go beyond the typical limits. Like I've seen us go beyond 100 gigabits per second using the Hitch TLS terminator, but if you use Varnish Enterprise's native TLS solution, you can go beyond 500 gigabits per second as measured and benchmarked by Intel. So let's have a look at some of the Q&As that came in anonymously. So the question is, how would this affect dynamic content? For example, logged in users, name showing on the front end. Excellent question. I have a separate presentation on that I deliver from time to time at conferences called Caching the Uncacheable. You might find some content on that online. But what we can do as well using edge-based techniques, we can actually load, for example, the name of a logged in person and compute that name on the edge, depending on whether you use cookies for that or you have a session storage or a database or an HTTP endpoint. We can load that and parse it on the edge. You can actually perform HTTP calls within Varnish to load that content. We can also interact with common key value stores like Redis, for example, where the session data might be stored. So that is one of the tricks I use in my e-commerce demo. This goes way beyond what I'm showing you here for a static website. So I hope this answers your question. Then another question, is there an opportunity for an expert system or AI and ML to train this or to do declarative coding in VCL? I haven't seen this before. Most of the times when we talk to clients and come up with VCL, we do a sort of audit process where we look at the typical endpoints they have, the cookie usage they have. We haven't used this with machine learning yet because in most cases we can solve it without. Now I know machine learning is all the rage these days. So I will pass that question on to our R&D department. This is an anonymous attendee asking the question. So if you are interested in following up on that, please contact us and we'll try to figure out if there's anything that is on the horizon in terms of AI and machine learning. And then we have another question, or one that was addressed more or less in the Q&A, like, is most of this Varnish Enterprise? Not everything. Like, let me take you to the code again. What is Varnish Enterprise, in fact? All of this is open source. This header plus thingy, you can do that with open source, but it will take you a little bit more code. This is open source. This is not, unfortunately, but if you can optimize your code, you'll be fine. But for people who cannot do that or would like to rely on us, you will need an enterprise vmod. All of this is open source, and this one is enterprise as well. So it's a bit of a 50-50 kind of deal. Then I have another question here. What is the most important metric is one of the questions. Well, in my opinion, it depends who you ask. Like, I always like to start off with time to first byte, because time to first byte really indicates how your server is performing. It's about the absolute loading speed. And but when it comes to perceived loading speed, I would say combine time to first byte with largest contentful paint, and I think you will go a long way. Most of the techniques I applied were there to improve both the first contentful paint and the largest contentful paint. Then we have another question coming in from Andrew. Andrew says, does Varnish support Brotli compression as well? It does. I deliberately didn't show it here. I went for gzip. Gzip performs pretty well, but Brotli is another compression algorithm that we support only in enterprise right now that can do further compression. But it's an enterprise vmod that also has a fallback to gzip. So it'll be intelligent enough to look at whether your browser does or does not support it. So if you look at how my browser does it, As you can see here in the accept encoding header, it supports gzip, deflate, and BR. So it stands for botany. We support that. So I guess we can leave it at that. If there's more questions, you can always contact me. I'm at Thijs Verin on all the social media. Let me take you back to the slides. So I'm Thijs. You can find me at Thijs Verin. So my handle is, let me type this here, at Thijs Verin on all the various social media. Someone will reach out to you as well. I would like to thank you for being here with me for almost an hour. Enjoy the rest of your day, depending on where you're based, or your evening. I enjoyed it. I hope you enjoyed it as well. And I will see you next time because there's more content to come. Cheers.